Good day and welcome to the AB 3411 Agricultural and Biosystems Power Engineering. In this lecture we will discuss the concept of power and energy, difference, units, and how to calculate power and energy. To begin with, I would like to start by saying power is not energy and energy is not power. To explain the difference of power and energy we will be using an analogy. Let's say you are a working student. Since you are working, then you have a money, salary rate, time of working. So, let's say money is energy, salary rate is power. If you have money it means you can buy things, same goes for energy. If you have energy you can do things. But to obtain money you need to have time to work in a salary rate, same with energy, you need time and power. You can have the salary rate in two methods, the high salary rate and the low salary rate, same also with the power, you have high power and low power. Having a high salary rate means you can earn more money at a given working time, which leads to more money to buy expensive things, gadgets, girlfriends, or boyfriends. Please note that the boyfriend and girlfriend is just a joke. To continue, having low salary rate means you can earn less money at given working time, which leads to less money to buy things, gadgets, cars, roses, girlfriends, or boyfriends, which will give you an option to buy those less expensive things. Substandard and second-hand cars, or no girlfriend or boyfriend at all. Please note that the boyfriend and girlfriend is just a joke. My goodness, what am I saying? Same also to the power. Having a high power means more energy at a given time, and having low power means less energy at a given time. Now let's put the time in our discussion. Let's say, you want to have a BMW M1000RR Superbike and a girlfriend as your back ride. You can obtain money to buy this in two ways. By working in a short-time job with high salary rate, in short scam others joke only, or long-time job with low salary rate. I think there is a shortcut, borrow money joke only again. These goes the same to energy. You can produce high energy using high power at a lesser time, or high energy using low power at longer time. I hope at this point you are not thinking that I'm just a jerk who wants to confuse your innocent mind and way of thinking. Well, if you are thinking that these things are nonsense, then I agree with you. So to make these topics to have sense, let's try to remember our 5 senses. Haha, that is just a joke. Please don't think that I'm just a jerk. Okay, back to the topic. To make the topic to have sense, we'll take a look at the unit. Money will have a unit of peso, salary rate will have a unit of peso per hour, and time will have a unit of hour. So, to make money, you will multiply salary rate and time, so the unit hour will be cancelled in the equation. Ha ha ha. If you do not know simple algebra, then please change your course. Joke, please review. You want to know your salary rate, then just divide the money with time, so you notice that the equation will have a unit of peso per hour. Now you can obtain working time by dividing money to the salary rate, which leads to a unit of hour. We can easily remember this by transforming into triangle, not diamond. We will divide the triangle in two sections, one at the top and one at the bottom. Now divide the bottom part into two like this. We will put the money at the top section since it is the most important in the society, and to not lose your girlfriend, then the salary rate and time will be distributed at the two bottom section. So now you will have a magic triangle. The key to have BMW M1000RR and a girlfriend is a back ride. We can easily assess our argument, if it is true or correct, because, if we increase the working time at a given salary rate, we can get more money. Same also to the salary rate. Increasing salary rate at a given time will yield to more money. This principle applies the same to power, energy, and time. Neither power or time will be changed. The effect is directly proportional to energy. Decreasing the time will decrease the energy, and increasing the power will increase the energy. Okay, enough for the analogy, and let's move to how to calculate power. Before you think I'm a jerk who only want a BMW M1000RR, not a Ducati Panigale 1299 V4R. Energy has unit of joule, and 1 joule is equivalent to 1 Newton meter. The Newton is a unit of force, and the meter is a unit of distance, so we can say that energy is equal to force times distance. Example, if you throw your girlfriend up to the sky at a vertical distance of 2 meters using 300 newtons of force, then the total energy you used can be obtained by multiplying the vertical distance of 2 meters and the 300 newtons force, which will have a total energy used of 600 newtons of meter, and don't forget to catch her so that she will not crack your nuts. Let's go to the power. Power can be defined as how fast the energy comes and leaves the system, or how fast the energy being generated or consumed. And this power has a unit of watt, and 1 watt is equal to 1 joule per second. In short, power is equal to energy over time. Important note, the word generated and consumed has a disclaimer, or scammer alert, because in the law of thermodynamics energy can neither be created nor destroyed, it can only change forms. So, we can conclude that the gasoline you put into your BMW M1000RR is not consumed by the BMW engine. Instead, the BMW engine transforms into a rotating mechanical energy at the back wheels minus the energy loss. Also, water turbine does not generate electricity, rather we can say that the water turbine converts the mechanical energy of the moving particles of water into electrical energy minus energy loss. So, finally, we come into conclusion that some point in your life you will lose a girlfriend, because of low salary rate. That is just a joke, but I'm not a jerk. So finally, we can say that regardless of the alteration between energy being powered expressed for a period of time, and power being consumed or generated for a period of time still holds true, so be true to your girlfriend also. This important dissimilarity of power and energy confuses many students, like how their girlfriend confused them. As your instructor, it is my responsibility to enforce this into your mind that power is energy per unit time, and energy is power multiplied by unit time. This can be illustrated using our magic triangle, by replacing money to energy, salary rate to power. Using the magic triangle, energy is equal to power multiplied to unit time, power is equal to energy divided by unit time, and time is equal to energy divided by power. In calculus, power is the rate of change of energy over time, and energy is the area under the curve of power as a function of time. But let's set aside the calculus that makes our nose to bleed. Instead, let's use simple algebra, together with our magic triangle, the key to have a girlfriend, to solve those super complex problem, like those complex girlfriends. Example, number 1, your girlfriend slaps your face using a 100 watt power at 0.2 second time. Calculate the energy released by your girlfriend, just to slap your face because you are not true to her. Your solution will start by identifying those known and unknown variables. Given power is 100 watt, time is 0.2 second and energy is unknown. Using the magic triangle, the key to have a girlfriend, we say that energy in joule is equal to power in watt multiplied by time in second. By substituting the value of the known variable into the energy equation, we'll have 20 joules of energy. Example, number 2. A calculator battery can deliver 10,000 joules in 2 hours. What is the power of the battery? Solution, the given known variables is energy 10,000 joules, 2 hours of time, and the unknown variable is battery power. We can calculate the power by dividing the 10,000 joules energy by 2 hours time, but we will convert the 2 hours into seconds, by multiplying to 3,600 seconds per hour. We can now finally calculate the total power of the battery, which is 1.38 joules per second. Remember that 1 watt is equal to 1 joule per second, so the battery power is 1.38 watt. Example, number 3. A bullet is fired carrying 400 joules of energy at 90 millisecond time. Calculate the power of the bullet. We can calculate this by dividing 400 joules of energy to 90 millisecond time, which result to 4,444.44 watts of power, or 4.44 kilowatts of power. Therefore, calculator manufacturer is smart enough to use battery to power their calculator instead of shooting bullet, but I hope to see someday a calculator powered by shooting bullets. Last, I would like to point out some confusing unit, like kilowatt hour. You always encounter this in your electric bills. This unit is for energy, even though the unit watt is present. This can be explained by changing the watt into joule per second, and converting the hour to second, which will lead to the cancellation of the time second, and the remaining unit is the joule. Another thing to remember is that joules are often used to small amount of energy, so when dealing with higher energy you use watts, kilowatts, or horsepower. Most of all, any power, which is 1 horsepower and above, can kill you, so please stay safe. Don't be afraid to your girlfriend because he is a human, not a horse, so she only have a 0.134 horsepower, not unless she have a calculator powered by shooting bullets. Then my advice is run run run.